what we're going to do here is we're going to look at how we can manipulate the graphs of sine x and cos x and tan x and get slightly different looking waves and so on. Now, first of all, what I'd like you all to do is if you download a piece of software called Geogebra, and then at the bottom of this YouTube clip there is a file on this web page, and if you load it up, because we're going to use this file to see how we can manipulate the graph and how we can change certain numbers around and do various things with it. Okay, so if you download the piece of software and then download this file, then we can see what changes we can make to the graph. Now here's the general template for a trig function. All trig functions look like this: y equals a sine b bracket x take away c plus d. Okay, now I can replace the sine with any one of these, any cos or tan. So y equals a cos b bracket x take away c plus d. Now, just like a y equals mx plus c graph, remember the m controls the gradient, the c controls the intercept, and so on. Well, these letters here, the A, B, C, and D, control these graphs in terms of what shape they make. Okay, so the A does something, the B does something else, the C does something else, and the D does something else. So what we're going to look at now is what these four letters do, and how we can get one or two pieces of information about the graph from them. Okay, so let's look at the first one. Okay, number one. Right, what does this A do? Okay, and it could be the same for tan. If I replace the cos with tan, it'll do the same thing. Now, if you recall transformation of graphs, if you take a function f of x and you just multiply the function by a number, if you recall what that number does, it stretches or compresses the graph in the y-axis, right? It either pulls it up, it stretches it up, or compresses it, but it only does it in the y-axis, right? Okay, that's what, and it does the same thing for these sine and tan and cos functions. So if we go to our GeoGebra software here, what we're going to do is we're going to change this bar, which represents the A value. So at the moment, this is just sine x. Okay, I haven't done anything to it. It's just 1 sine x and then bracket 1x, and so it's just sine x. And I'm going to change this value A to 2. And if you look at it, this number here, this one here is going to change, right? So let's see what happens. If I change it, you can see it's growing, and then when I change it to 2, the height of it's changed to 2, and it's 2 below as well. It's 2 above the principal axis and 2 below the principal axis. So what this A does, it controls the amplitude of the function. Okay, so it controls how high the peaks are or how low the troughs are. Okay, so they would be whatever A is, that's how high they will be. They'll be A units high. Okay, so that's what this number here does. It doesn't really do it for tan, because remember, tan's got these asymptotes, so you have to kind of try and imagine it being stretched. But for sine and cos, it just pulls the peaks and troughs up. Alright, let's look at the next one. Okay, let's look at the letter D instead. Right, let's see what that does. Right, remember, if you take a function, if you recall, and if you add or take something away from that function, all it does, it moves, okay, a fancy word for move, it translates the graph vertically. So it moves it up or down depending on what D is. So if we go to our bit of software, let me change this back to what it originally was, 1. Okay, here's the bar for D. If I change it to 1, you can see it's moved the whole graph up 1 unit. And a good way to see that is if you look at this peak, it's 1 high at the moment. If I change D to 1, okay, I've got a +1 at the end, it's changed it to 2, right? But what it also changes is the principal axis. Remember, the principal axis is the middle of the wave. So it controls the principal axis, and actually the principal axis y equals, okay, for our original sine x function, if I change it back to 0, y equals 0 is the original one, but if I change D to 1, it becomes y equals 1. Well, the general thing to remember is y equals D is the principal axis. That's where the middle of the wave is. So you've got your wave going like this, and y equals d would be running through the middle of it. Okay. Right, now let's look at the next one. Let's look at the letter B and see what that does. Right. If you recall, if you take a function and you multiply x by something and then put it into the function, right, if you recall what that does, that stretches or compresses the function depending on what value of b you get in the x-axis. So it stretches it or compresses it. So it either compresses it by pulling the graph in or stretches it depending on what b is, and only in the horizontal axis. Okay, right, so let's just see that in action. If I change d back to 0, right, here's b. I'm going to change it to 2 now. Look at this key point here. Remember, this graph has a period of 2 pi. That means one complete wave. Okay, so if you start here, you see you go up, down, and then 2 pi later you get back to it, the same kind of starting position, and then it repeats. So the period of the wave is 2 pi. Now watch what happens to that period when I change this. If I change b to 2, okay, yeah, it does compress it, but what's the period now? Okay, if you look at one complete wave, okay, if you start here, it goes up to the top, back down, and back to pi. Well, that's it. The period's changed to pi. So it was 2 pi, that was one wave, and now it's changed to pi. So it's changed the period of the wave. It's squashed it by a half, effectively. Okay, so what I want you to remember is, and it works for sine as well, actually. Let me just go back. Let me just show you. Let me change it back to 1. Okay, so the period is 2 pi. Let me change this to cos x. Let me change my base function to cos x. Cos. Okay, you can see if we start, okay, cos, remember, starts at the top at 1, and then 2 pi later you get back to your starting point. But if I change b to 2, it squashed it by a half, and you can see if I start at 1 pi later I get back to this. And if I change b to a half, let me change it to 0.5, yeah, it stretches it by a factor of 2. Yeah, so if you look at the period now, if I actually move across, if I look at the period now, let me squash this a little bit. Okay, so if you look at the period, starting at 1 at the top, 4 pi later, it's repeating itself. Okay, so b controls the period. Okay, so if I change it back to 1, this is our basic one. 2 squashes by a half, and 4 pi, and a half stretches by 2. But what I want you to remember is this: for the sine and the cos, this is how you can work out the length of one wave, the period. Okay, remember this little formula: the period, which is how long one wave is, and it's for the same for sine and cos. It's 2 pi divided by whatever b is. So if you recall, when we changed b to 2, if you did 2 pi divided by 2, okay, they cancel out, you're left with pi. That's the length of one wave. So one wave would be pi units long. Okay. Right, now let's look at the third and final letter, the letter C. Sorry, not the third and final, the fourth and final letter, C. Right. Oh, sorry, hang on, backtracking just a little bit. This is quite important, actually. Right, for sine and cos, this is the formula, okay, to remember for the length of the period, but it's different for tan. Okay, tan doesn't repeat itself every pi degrees. Let me change it to this. Tan has a different period. Tan repeats itself pi, right? Tan repeats itself pi. So what you want to do for that is, for tan only, the period is pi divided by b, okay? So you would do pi divided by 2, which would be a half pi. That would be the length of one of those blocks. Okay, it would be pi divided by whatever b is. That's because pi is a different oscillating period. It's pi instead. Okay, right, now let's look at the fourth and final one. Let me do it over here because I need some space. Okay, the fourth and final one. What that letter C does. Now, if you recall, if you take a function and you subtract something from x and then put it into the function, this translates the graph horizontally, right? Horizontally. So it moves it left or right depending on what c is. So if I did this, f of x take away 5, I changed c to the number 5 and I did x take away 5, this taking away 5 moves it, okay, if you recall, it moves it in the opposite direction to whatever I set this to. So if I take away 5, it's going to move it 5 places to the right, okay? So it's going to move it 5 places to the right. So if I set c to 5, if I set that to 5, then it moves it 5 places to the right. But in function notation, I have to write x take away 5 to move it 5 places to the right. So c just translates the function left or right. So if we, let me press Control Z to, actually let me change that back to sine x. Oops, let me change it back to sine x. Okay, and here's the bar for c. Now, what I want you to look at is this. Okay, look at this. At the moment, it's doing x take away nothing because I've set the bar c to 0. But if I change it to, that's actually 0.75 is a quarter of pi. Okay, and it's got x take away 0.79. Okay. Or if you actually did pi divided by 4, that's that. But it's x take away 0.79. It's taking away whatever number I set that to. And if you look at it, if I change it back to 0, you can see, look at this key point here. Look at it sort of moving here. Can you see it's 0, then it's moved. 0, and it's moved. So it just moves it however many places I've set this number to. So that translates it. Okay, and it does the same thing for tan as well. So you've got the 4 key bits to remember, really. Okay, this controls the amplitude, the height of the wave. This controls the period, that's the length of one complete wave. This moves the wave left or right, okay, depending on what c is, and this last number moves it up or down. Okay, and they're the 4 things to remember. And remember the period. If you want to work out the length of one wave, for sine and cos, it's 2 pi divided by whatever value you set b to. But for tan only, it's pi divided by b. Okay? All right, what we're going to do now is we're going to look at, what we're going to do next, sorry, in the next clip, is we're going to look at how to sketch the graphs of sine, cos, and tan after they've been manipulated somehow. Okay?